Okay, we're going to learn how to write half-cell reactions and how to use those half-cell reactions to balance the redox equation. Okay, so let's go ahead and get started. Alright, let me just get my mouse working. Alright, so what we do is we have an equation and it's not balanced. And what we do first is we identify all the oxidation numbers. So sodium is 0 because it's an element. Iron is 0 because it's an element. Here chlorine is a -1 because there's two of them. The iron must be a +2. Sodium is +1. Chloride is -1. Okay, so we have to identify, there's three elements involved. We have to identify which two have changed oxidation number. And here we've got a sodium has gone from 0 to +1. So I'm going to write that down here. Na0 has gone to Na+1. And the iron has gone from +2 to 0. So iron has gone from +2 to 0. And if you notice, the chloride has not changed. It's -1 to start, and it's -1 as a product. Okay, so now I've got to balance these using electrons. So here I have a neutral charge, 0 charge. Here I have a +1, so I need to add electrons on this side, +1 electron here. I need to add electrons here to balance this, so I need 2 electrons here in order to make this balance. +2 -2 gives me 0. Alright, and then what we want to do is we want to use this to balance. So I have 2 electrons being added here, and I have 1 being lost here. I've got to have my electrons even or balanced, so what I need to do is multiply this whole thing times 2. Okay, so I'm going to take this 2 and carry it up to any place that there's a sodium, and that will give me my balance equation. Now I need to identify where I need, where I have oxidized and where I've reduced. So to me, it's easiest to identify where my charge has gone down from a +2 to 0. The charge has reduced, so this is reduction, and this is oxidation. You can also use the good old LEO, loss of electrons. If I'm losing electrons, I'm oxidized. If I'm gaining electrons, I'm reduced. Okay, let's try the next one. Here we have water being formed from hydrogen and oxygen. Hydrogen is an element, starts at 0. Oxygen is an element, starts at 0. Oxygen is -2. Each hydrogen is +1. So both of these change. The H2, and I want to carry that subscript down, goes from 0 to H2 +1. And the oxygen goes from oxygen, the O2 0, to O -2. Now, as soon as I know I've got 2 over here, I need to give that 2 a coefficient here. Okay, so let's balance the electrons. I've got 2 that are neutral, 2 that are +1, so we need 2 electrons here. And here I have 2 times -2 is -4, so I'm going to have to add 4 electrons here to get that to balance. So now I have 4 electrons being gained here, 2 being lost, so I need to multiply this times 2 in order to get this electrons to 4. So any place there's an H2, I'm going to put that in front, and that will balance it. Now I need to identify which element is reduced, and it's the oxygen because it goes from 0 to -2, so that's reduced, which means the hydrogen must be oxidized. Alright, so here copper starts as 0. Hydrogen is 0. Elements are easy to identify because they're always 0. Here we've got nitrate. The oxygen is a -2. Hydrogen's a +1. My total negative charge here is -2 times 3, or -6. I have a +1. So to make this whole thing be neutral, I've got to have nitrogen be +5. Okay. I can do the same thing here. What I know is the nitrate itself is a -1, so the copper must be a +1. And within the nitrate, these are going to have the same charges, so the nitrogen is going to be a +5, oxygen a -2. Okay, so my copper went from copper 0 to copper +1, and my hydrogen goes from +1 to H2, which is 0. Because there's a 2 here, I immediately got to put a 2 in front of this. Okay? Alright, to get my electrons to balance, I need +1 electron here. I'm going to need 2 electrons here to get this to balance. Okay? Because there's 2 here and 1 here, I have to multiply this whole thing times 2, which means I'm going to need 2 of those and 2 of those. And I also have to carry up this 2 I wrote here. That 2 is going to need to go here. And that'll give me a balanced equation. And in order to identify what's reduced, the hydrogen went from a +1 to a 0. So that's reduction. And I go from 0 to +1. That's oxidation. Okay, let's look at the next one. Alright, I have silver nitrate. So silver as an element is 0. Copper as an element is 0. Let's do the whole nitrate. Because nitrate's a -1 and each oxygen's a -2, that's a total of -6, nitrogen must be +5. So it's going to be the same on both sides, +5, -2. This is 1 nitrate, so the copper must be a +1. And here, again, 1 silver. So, nitrate's a -1, silver must be a +1. Okay. So, my silver goes from +1 to 0. My copper goes from 0 to +1. So I have silver at +1 going to silver 0, and I have copper at 0 going to copper +1. So I need 1 electron here, and I'm going to need 1 electron here. Electrons are balanced, so that's good the way it is. Now, I need to identify what's reduced. In here I have silver going from +1 to 0, so that must be reduced, and I have this copper going from 0 to +1, so that's going to be oxidized. Okay, let's just go back for a second. I want to check one thing. Okay, so I was just checking when we put the 2 here in front of this O, we wanted to make sure there's a 2 here, so we're good. Okay, we're going to stop there.